In many ways, black holes are the most extreme objects in the universe. They literally pack a huge mass into a smaller volume of space, bending the fabric of space so much that once anything enters a certain area, it can never escape, even if it moves at the ultimate cosmic speed, the speed of light. Apparently, trillions of black holes are distributed in each galaxy of the universe, like our Milky Way, and the largest of them reach billions of solar masses. And yet, if we think about how all these black holes were formed, we can confidently say that each of them was originally made of ordinary matter. None of them were formed from dark matter, even though dark matter exceeds ordinary matter in the universe by a ratio of 5-to-1. But if black holes are the result of gravitational force, and if dark matter responds to it, then what prevents the formation of a black hole from dark matter? Today we have a space story about whether black holes can consist of dark matter. In our modern universe, there are only a few known ways of creating black hole. Perhaps the most common method is the collapse of the core of an extremely massive star. The only thing that prevents a star from collapsing under its own gravity is the energy produced by nuclear fusion in its core, where external radiation pressure balances the internal gravitational force. When the fuel that a star burns runs out, the radiation pressure begins to drop, and the star's core begins to shrink under the influence of its own gravity. As the core shrinks, it heats up to a temperature that is difficult for an ordinary observer to imagine, and the higher the temperature, the greater the chances that the core can start burning even heavier elements, using them as fuel. After these elements are exhausted, the core will collapse as a result of a Type II supernova. If it is massive enough, a black hole will form due to the accumulation of an enormous mass in such a tiny volume of space. If the core is not massive enough, a neutron star will be born. In addition, a black hole can also form as a result of the collision of two neutron stars, provided that the total mass after the merger exceeds a certain threshold. Finally, a black hole can form as a result of direct collapse, when, for example, a single massive star simply becomes too dense for light to escape from a certain volume of space. Once this condition is met, an event horizon will form, and anything that crosses it is guaranteed not only to never escape, but also to quickly increase the mass, and therefore the size, of the forming black hole. In a short amount of time, it can consume all the mass of any object from which it was formed, and then another black hole will appear. Other exotic ways of forming black holes can certainly exist, but it is believed that the above methods are responsible for the overwhelming majority of existing black holes in the observable universe. As you may have noticed, all of these methods have something in common. They are based on ordinary matter consisting of atoms and their components. This becomes even more amazing when you consider a number of facts. Ordinary matter makes up only 1/6 of the total mass of the universe, while dark matter makes up the remaining 5/6, and both normal and dark matter experience gravitational force equally, following the laws of gravity of both Newton and Einstein. In any medium where there is an abundant amount of normal matter, such as in a galaxy like the Milky Way. In general, there is significantly more dark matter in the Milky Way than normal matter, with a ratio of at least 5-to-1. But then why can ordinary matter so effectively form black holes, while dark matter cannot? The key lies not in the force of gravity, but in other forces. Things like friction and collisions that depend on electromagnetic interaction affect ordinary matter, but not dark matter. When a galaxy forms, dark and ordinary matter typically form in a ratio of 5-to-1. This happens on average throughout the cosmos, and all particles subject to gravity are attracted toward the center of the gravitational potential, accelerating in that direction. Here's where it gets interesting. When dark matter passes through a galaxy, it experiences no friction or heating, and there is no opportunity to exchange energy or momentum with other existing particles within the galaxy. As a result, it remains on a slow orbit with high angular momentum, and it may take about 1 billion years to form a complete ellipse. In contrast, ordinary matter has everything dark matter lacks. It collides with other matter, dissipating energy, and as a result, it can settle into a disk shape more quickly than dark matter. An orbit with a large angular momentum may take about 1 billion years to form a complete single ellipse. Ordinary matter, on the other hand, has everything that dark matter lacks. It collides with other particles of baryonic matter, which can exchange energy and momentum. Particles can collide, resulting in losses of kinetic energy and angular momentum. They experience friction and heat up when interacting with other particles of ordinary matter and respond to radiation. Taken together, all of these phenomena lead to a significant difference that can be summarized as follows. Ordinary matter loses angular momentum and moves down to the nucleus of the galaxy, while dark matter always remains diffusely distributed in a vast space, creating a halo around the galaxy. Dark matter can never even approach the density necessary to create an event horizon, and therefore there are no black holes made of dark matter. There are no regions that ever collected enough dark matter to attract light back into them. And this means that there is no dark matter subject to direct collapse, and there are no stellar remnants or other relatively dense objects made of dark matter. Consequently, there is no way for collisions between dark matter-rich objects to form black holes. All the mechanisms by which ordinary matter can collapse into a black hole do not apply to dark matter. Now it becomes clear that when a black hole is formed from ordinary matter, dark matter particles cannot cross the event horizon and increase the mass of the already existing black holes. In terms of dark matter, it is no different from any other form of matter or radiation. When crossing the event horizon, everything inevitably falls into the central singularity and ultimately increases the total mass of the black hole. However, due to the clumpy nature of ordinary matter and the diffuse nature of dark matter, there are no realistic scenarios in which even 1% of the total mass of a black hole could be obtained from dark matter. In fact, based on our current understanding of the universe, there is only one possibility for ever creating a black hole from dark matter. This would occur only if the very early universe had fluctuations of a sufficiently large magnitude that would quickly collapse and form a black hole long before the formation of any stars. If this were to happen, it could create one or several primary black holes that would exist independently of stars. This is the case where only mass matters, since the calculation is based solely on the physics of gravity. It allows us to determine how large the excess density needed to form a primary black hole independent of the mean density is. If the universe is born with an area that is locally 68% larger than the given mean density, it will lead to gravitational collapse and the formation of a primary black hole. And now we have a universe that was born with a spectrum of fluctuations, and these fluctuations gave rise to structures that we see everywhere in the universe. We see the consequences of these fluctuations in temperature defects in the cosmic microwave background. The signature of the cosmic microwave background in features such as correlation functions and the power spectrum of the large-scale structure of the universe. When it comes to scientific conclusions, it is important to ask the right questions and not succumb to the temptation of mistaking what we want for reality, instead of asking if it can be imagined. The temptation to mistake what we desire for reality, instead of asking whether a scenario can be imagined that would circumvent current constraints, which would at best give us a possibility, must be resisted. To ascertain whether a claim is true, we must examine the evidence and ask minimal additional assumptions what the universe tells us about itself. This crucial question of what is true lies at the heart of all science. From a scientific point of view, it is irresponsible to draw conclusions about the truth of a hypothesis without evidence in its favor. When it comes to dark matter, which we understand as it stands, we can expect that there are no black holes today or ever consisting mainly or exclusively of dark matter, and there are no stars, supernova remnants, or scenarios of direct collapse that should have led to a black hole consisting of this matter, and there is no way for this matter to be dense enough to form a black hole after the universe began its existence. Unless we turn to a new but unobserved physics to cause the creation of a certain spectrum of primary black holes composed of dark matter, we can confidently say that it is ordinary matter, not dark matter, that is responsible for the black holes we observe today in our beloved universe. Don't forget to give this video a thumbs up and subscribe to the channel if you haven't already. See you in the next interesting encounter.
As you all know, a black hole is one of the scariest things in the universe. Once you cross the horizon of an event where such a space monster is involved, there is no turning back. But what if we experienced it a long time ago? What if the entire universe was a black hole and we were already inside it? Let's first think about what commonalities there are between the universe and a typical black hole. A black hole is formed when a massive amount of matter contracts to the point where it cannot be seen even with powerful microscopes and collapses. In the case of a stellar mass black hole, the core of an exploded supernova collapses, while in the case of a supermassive black hole, a large cloud of gas and dust or a giant protostar collapses in its entirety, but the principle is the same in either case. The gravity of celestial bodies depends on their density, as you may have learned in physics class. Density can be calculated by dividing mass by volume. Black holes have a massive amount of mass, but have an extremely small volume, so the gravity on their surface is very strong, and even light cannot escape at the speed of light. Matter is condensed into a very small point. Even if one is located at a certain distance from the singularity, the area where gravity is so strong that nothing can escape is called the event horizon. In the images or illustrations of black holes, it is the black sphere-like object. Outside the event horizon, black holes behave like any other celestial body with the same mass, affected by gravity but not absorbing anything. It is like how the sun does not absorb the Earth. This means that there could be normal planets capable of escaping near black holes. However, what we are more interested in now is the interior of a black hole. Of course, we cannot directly investigate the interior of a black hole. Furthermore, if we cross the event horizon, we cannot stop or turn back as time almost stops due to the strong gravity, and space itself loses the property of time. Similarly, within a black hole, space cannot be reversed. Once you cross the event horizon, you have no chance to stop or return and can only fall towards the singularity. In fact, the fact that it cannot be crossed is the biggest common point between the universe and a black hole. Among the phenomena occurring in the universe, there are a few that can only be explained by the influence of the gravity of another universe. The substance of one universe cannot move to another universe. The substance of the universe is not contracted into a very small volume, but the opposite is true. However, in reality, singularities and black holes do not have a uniform shape, unlike abstract mathematical black holes. In the case of a rotating black hole, the singularity has a ring-like shape. Although it is very small, it is not zero in size. Anyway, size is a relative thing, so to speak. For humans, viruses are extremely small existences, but conversely, for viruses, humans are extremely large existences. Of course, it is possible to argue that we are not moving towards the singularity in the universe. However, if all the material in the universe has already collapsed into a singularity, isn't it just that there is no place to move? Through these hypotheses and fine-tuning, scientists have come to think that the universe may not be a giant black hole. This concept is called the Schwartzschild's little universe or black hole universe, and it was first revived by Indian scientist R.N. Iyengar and British astrophysicist A.G.S. Venturini in 1972. There are also interesting theories about black hole universe proposed by modern famous physicists, such as the one by Lee Smolin. He faced the fine-tuning problem of the universe, which troubles many scientists. Our universe exists thanks to the existence of many constants. For example, if one constant had changed slightly, there might not have been heavier elements than boron, and stars might not have formed. Life itself, including intelligent life, might have been impossible. Additionally, in the multiverse theory, it is believed that there are countless universes, each with its own independent fundamental physical constants. However, in our universe, physical constants happen to be suitable for the birth of life by chance. This is similar to the idea that only Earth among the celestial bodies in the solar system has the conditions for the birth of life. Smolin developed this hypothesis further. He expected that the universe was repeatedly multiplying through the power of black holes. Every time a black hole is born, it has its own unique physical constants, different from those of our universe. He believes that a new universe has been born. According to Smolin, the constants necessary for the birth of life are also necessary for the occurrence of black holes in the universe, and as the number of black holes increases, the offspring produced by the universe also increases. If it is confirmed that we are living inside a black hole, it would be strong evidence in support of Smolin's theory. However, we cannot directly confirm whether the universe we observe from outside is actually shaped like a black hole. Therefore, to determine whether the Schwartzschild spacetime is correct or not, we must rely on indirect evidence. In the scientific community, there are concepts such as the Schwarzschild radius or the counterattack against the Schwarzschild spacetime regarding black holes. These concepts are based on the mass of the black hole. The term event horizon radius refers to the radius of the horizon of an event. For example, if calculated by the mass of the Earth, this value would be less than 1 centimeter. This means that if all the matter on Earth were to collapse into a singularity, the radius of the event horizon would be this value, indicating the birth of a black hole. In addition, if the Sun were to collapse, a black hole with a radius of 3 kilometers would be formed. Various calculations have shown that if all the mass in the observable universe were to collapse, the Schwarzschild radius would be between 10 and 13 billion light-years. If the black hole hypothesis is correct, the Hubble radius would also be almost the same. The Hubble sphere refers to the virtual sphere that expands around an observer, and beyond this range, all objects are no longer visible because they move away from the observer at a speed faster than the speed of light due to the expansion of the universe. The radius of the Hubble sphere is 14.4 billion light-years. In other words, the Hubble sphere is larger than the Schwarzschild radius of the observable universe. There are researchers who support this idea, while there are also researchers who claim that the concept of the Schwarzschild radius is fundamentally flawed. They point out that there are other issues with this model and the related Smoluchowski hypothesis. For example, a black hole is not a physical object in itself. Like other celestial bodies, something is always pouring into it, mostly gas or dust from space. As this material falls into the black hole, its mass increases, although the increase is negligible. On the other hand, we do not see any evidence of stable matter supply from somewhere in our universe. Also, black holes regularly collide with other planets, stars, or other black holes, which is a very rare phenomenon, but it does happen. Our universe may have experienced similar collisions over billions of years, but there is no concrete evidence of such collisions happening. The existence of whether we are actually inside a black hole or not is still a matter of debate and has not been confirmed at this time. But as ordinary humans, all we can do is turn our eyes to space in pursuit of new discoveries. Even if we knew whether the universe is a black hole or not, the fact that the universe is beautiful and magnificent would not change. Please subscribe to our channel and hit the like button, and don't forget to share the video on your social media. What would happen if there were a black hole in our solar system? This is the topic we will explore, especially from the perspective of Earth's satellites. Mass, concept, and numbers. First, let's clarify the concept and numbers a little. Known black holes are formed by a vast amount of matter collapsing into a small space, most often from a star, including very massive stars. The typical mass of a black hole that astronomers have been able to detect is at least 3 to 5 times that of the Sun. Of course, if there were such a black hole where we could stand, we wouldn't be orbiting around the Earth. Instead, the Earth would become its satellite, orbiting around it. But in theory, any amount of matter could be compressed into a singularity, creating a black hole. Therefore, for the purposes of this video, we will assume that our hypothetical black hole has a mass similar to that of the Moon. How could such an object come into being? It could be born from some anomaly, or it could have been born for an alien experiment. More accurately speaking, the event horizon of a black hole is very small, about 0.1 millimeters in size. Earth is not sucked into it because black holes behave the same as celestial bodies with the same mass. However, its effect on Earth is very interesting. To talk about the effect of such a black hole on Earth, it's best to start with something simple. For example, let's start with the appearance of the night sky. A black hole with stellar mass would have a bright accretion disk surrounding the black sphere, creating a very beautiful spectacle. You might have seen this kind of image in an illustration, science fiction movie, or computer game, but please forget about the image this time, as it doesn't apply in the case we are discussing, as I mentioned earlier. Black holes with masses similar to the Moon are very small. They have a strong gravitational force, but they are so small that at best, we can only see faint patches in the sky on a regular basis. In the worst case, it may not be until the space age that we realize the existence of black holes. Instead of solar eclipses, we may observe the sun through a gravitational lens caused by a black hole. Light passing through the side of a black hole is distorted by its gravity. Therefore, when the Moon passes between the Sun and the Earth, we can briefly observe a faint distortion on the solar disk. Also, when the Moon is between a star and the Earth, the star that is the source of light appears differently to us due to the lens effect, such as appearing to emit momentary flashes like some other stars, or appearing to expand slightly. However, because black holes are so small, we can observe these phenomena only through high-performance telescopes. There is a deep connection between our culture and the Moon, historically. The first calendar was likely the lunar calendar, no matter when it was made. The periodic changes in the size of the Moon can be easily observed if there is only 1 month, but it is difficult to calculate it in areas where there are only rainy and dry seasons. If the Moon were to become a black hole, the spirits would naturally become unknowable. This would cause a significant delay in the development of not only astronomy but also civilization as a whole. In reality, time would only be measured in day and night, and it wasn't until the Stone Age that the concept of a year could be recognized. However, this is a story of when the Earth could somehow escape the destructive effects of a black hole, which may be quite difficult. As I mentioned before, this is the story of the eternal end. When a black hole appears nearby, it is very small compared to the many major changes that occur. It also affects the Earth's gravity, not just cars, but also constantly swirling to prevent other parts of the Earth from cooling down. Even if there is a black hole instead of the Moon, there will still be tidal effects on the Earth, but because of its small size, the tidal effect appears to be concentrated in a narrower range and at a pinpoint. However, it will act more strongly. Near the equator of the Earth, natural disasters such as volcanic eruptions or earthquakes will occur intermittently. As a result, life will become practically impossible, and there will be a significant impact on the Earth's climate. Due to this geological activity, the Earth is getting warmer, and the transparency of the air is decreasing due to the continuous emission of volcanic ash. Earth will become darker and hotter in such an environment. Before we even consider whether humans can be born in such a scenario, it is unknown whether life can survive at all. It is entirely possible for Earth to become like Venus. Another problem is radiation emitted from the Earth's satellites. Black holes, in particular, emit severe radiation from their accretion disks. In this case, interaction with solar winds and the Moon's magnetic field may also occur. Perhaps the Earth will be bombarded with constant streams of various particles, and it is unknown whether the Earth's magnetic field can protect it. If it cannot, after hundreds of millions of years of radiation exposure, all of the Earth's water will decompose due to the radiation's influence. Without radiation protection suits, the Earth will become an endless barren wasteland where nothing can survive. Of course, in such a scenario, no form of life could exist. Finally, there is a phenomenon called Hawking radiation, which suggests that any black hole will consume energy and mass over time and eventually evaporate. Particle pairs are created and evaporate, which is a very gradual process. For a stellar mass black hole, it would take endless time with dozens or hundreds of pairs sticking together, while a black hole with the mass of the Moon would take only billions or trillions of years. In theory, the smaller the mass of a black hole, the more actively the particles mentioned earlier are created, causing another problem for us. As the particles rain down on Earth, they create confusion in the magnetic field and cause geomagnetic storms one after another until the last one explodes and dies. Of course, that is if it hasn't been swallowed by another black hole by then. There is also a theory that there are many small black holes in the universe, which are considered as one of the candidates for the role of mysterious dark matter. These black holes are thought to have emerged after the Big Bang because they have certain properties that satisfy the matter and space. If this hypothesis is correct, theoretically, it is also possible for Earth to have such a satellite. Lastly, there is something I would like to say. The possibility of such satellites being born in the solar system is low. In such cases, black holes will swallow all matter in the gas and dust cloud phase and grow to become a normal-massed black hole. However, there is a good chance that they may come from somewhere in a completed star system far away. Certainly, there has never been a similar phenomenon observed in an alien planet. Therefore, the possibility of such an event occurring seems low. If this video was helpful, please hit the like button, which is the greatest strength and motivation for us. The observable universe spans an area of approximately 90 billion light-years, and it can be assumed that the part of the universe we cannot observe is much larger. The cosmos is so vast that the human mind is simply unable to comprehend it, at least for now. However, according to some theories, it is possible that the universe is significantly smaller than it appears. According to current estimates, the unobservable part of the universe may be around 20 trillion light-years in diameter. Just imagine, based on the data we have, we can assume that most of the cosmic space should be empty because the amount of matter in the part of the universe we have explored is relatively small. When we gaze into space, we see vast, incomprehensible expanses of icy emptiness. But what if the universe could fit in one atom? It may sound absurd, but don't dismiss this theory too quickly. It is more like philosophical science fiction. It may not be so unbelievable, but first, let's recall what we know about matter. Any matter is made up of the smallest particles, atoms. These tiny building blocks of the universe, as we know it, are so small that even with the help of the most powerful optical devices, we cannot actually see them. Interestingly, we cannot even know with sufficient certainty what they look like. We can only speculate based on scientific theories. However, it is considered a proven fact that atoms cannot be seen with the naked eye, and the fact that atoms themselves consist of smaller subatomic particles such as neutrons, protons, electrons, and quarks is now well established. Atoms are so numerous and small that the body of an average adult human being consists of approximately 7 octillion atoms. To put this number in perspective, it can be represented as a 7 followed by 27 zeros. Just imagine this amount, but the atom itself also has its own structure, a complex structure that allows us to contemplate the incredible theory of the microuniverse. How does an atom look like from the inside? From your high school chemistry class, you probably remember that an atom consists of a nucleus formed by protons and neutrons, and electrons moving around it. This model, proposed by Ernest Rutherford in 1911, was named the planetary model of the atom. Indeed, the analogy between the movement of atoms around the nucleus and the movement of planets around the sun is evident. Moreover, this model has not been refuted and is even confirmed by modern research. It turns out that the movement of electrons is described by the laws of quantum mechanics, rather than classical physics. Thus, the smallest particle that forms the basis of matter has a structure similar to that of the solar system. Is this a simple coincidence due to the laws of physics, or does this similarity hide something bigger, something much more fantastic? We will return to this question later. For now, try to answer the question of how many galaxies there are in our universe. It sounds absurd, doesn't it? Such a number cannot be processed even by the most powerful computer, let alone the human brain. But what if I told you that there is only one electron in the entire universe? This hypothesis, called the one-electron universe theory, was proposed by American physicist Richard Feynman, and it sounds like pure fantasy. According to this theory, there is only one electron in the world that moves through space and time so fast that it appears to us as if there are many of them, giving shape to everything we consider to be the entire universe. What do you think of this? Of course, this theory has not found many supporters, but the most interesting thing is that due to the principle of identity, it is impossible to experimentally distinguish one electron from another is impossible. This paradox cannot be refuted. But let's return to the structure of the atom and the incredible theories it gives rise to. Let's try to answer the question of what size objects are. Despite the everyday, familiar meaning of this word, the concept of size is quite mysterious and relative. For example, the world around us is adapted to our size because we built it. But with the creations of nature, it's not so simple. Mountains are huge for us, planets are gigantic to the point of being impossible to comprehend, but for an ant, all forms of life range from simply small to microscopic. However, do ants consider themselves small and understand that they live in a world of giants? Probably not, as their world is just as familiar to them as ours is to us. Compared to cosmic objects, we are even less than microscopic. This thought gives us goosebumps, and it's no wonder that the great master of horror and science fiction, H.P. Lovecraft, promoted the idea of the insignificance of humanity before the face of the boundless cosmos in his works. And now we come to the main question of our video: what if our universe can fit on the tip of a needle? Suddenly, the solar system and you are just one of the myriads of similar entities that make up some other matter. Rejecting this version is illogical, so we can assume that the same is true for the particles that make up our existence. It turns out that, as one wise man said, infinity is truly limitless. This means that our reality could really be on a subatomic level of a completely different reality. Similarly, entire worlds could also be located on our subatomic level, and so on to infinity in both directions of scale, which sounds incredible, but exploring the incredible is our job. The most interesting thing is that by looking at the universe we know and observing the laws that function within it, we can easily come to the same conclusion. Everything begins with the smallest particles like atoms and ends with colossal celestial bodies and entire clusters of stars, starting with your lunch today and ending with a recently discovered exoplanet. Everything consists of the same building material. Finding the theory of everything, which relates the micro and macro worlds, is the dream of the scientific community. Combining quantum mechanics and classical physics, young scientists may be able to understand the true nature of our universe, even beyond its boundaries. According to one of the most popular versions of the origin of our universe, it began as an infinitely dense and yet small singularity, which then expanded to all known limits. This is called the Big Bang Theory, from something small to something very big. It also seems to correlate quite well with what we talked about today, micro and macrocosmos, but there is an important remark. It's not that it originated from one atom. There was a singularity that gave birth to the Big Bang. Despite its small size, it contained everything necessary for building the entire universe, but calling it the origin from one atom is not accurate. There is also the so-called string theory, an excellent candidate for the theory of everything. The basic idea is incredibly complex and has many interpretations. The theory suggests that the singularity is not a spherical object whose shape and appearance we remember from school, but rather strings or something very similar to them. The relationship between these vibrating strings includes almost all known laws of classical physics, including gravity and quantum mechanics. However, the string theory also has its weaknesses. Although it explains a lot, it begins to stumble when it comes to dark matter, where the string theory starts to sag. But scientists have been working on incorporating it into the theory. In late 2018, Swedish scientists published a new version of the string theory, which suggests that our universe exists on the border of a constantly expanding bubble. This version rejects the familiar 4 dimensions of 3 spatial and 1 temporal and suggests that our entire universe is just vibrations on the surface of this bubble. What happens inside the bubble or at a distance from it remains a mystery. How do you feel about these perspectives? We are just a small civilization and a tiny piece of reality located on the surface of the bubble, which itself could be a part of something much larger. Perhaps our entire world is just a proton or a quark, just a small particle of reality. Why don't we feel it? Does it feel like the components in your sunglasses, which are just plastic? But is it really important to get a definitive answer to this question? Ultimately, we should just be grateful that our vast and shared home called the universe is full of such amazing mysteries. Getting to know these mysteries is our task, and we hope you enjoyed our video. Write your thoughts in the comments. Don't forget to like and subscribe to the channel for more content. If there was one of the brightest and most destructive phenomena in modern space, it would be a supernova explosion. Hello to all of our viewers. In this video we will introduce particularly interesting things from supernova explosions, not scientists. We will skip the lengthy introductions and get started. LMC N49 is a supernova that exploded about 5,000 years ago in the Large Magellanic Cloud, a companion galaxy to our Milky Way. Unfortunately, it cannot be seen from Earth because it is about 160,000 light-years away. However, if the supernova had been closer to Earth and existed during ancient times such as the Sumers in the southern hemisphere or ancient Egypt, it would have been recorded as the first supernova explosion in history. LMC N49 is believed to have been a very bright and massive unstable star. Supernova explosions are a profound phenomenon, and one that is clearly displayed is G1.9 plus 0.3. This supernova explosion is the most recent of this type of event to occur in the galaxy. The supernova exploded in 1899. Imagine, the 20th century was a time of dramatic scientific and technological advancements, as well as social and political upheavals. Now, well into the 21st century, there has not been a single supernova explosion among the trillions of stars in the galaxy during this period. Is the universe laughing at us? Scientists sometimes have such thoughts, and G1.9 plus 0.3 is one of the pieces of evidence. Although the supernova explosion occurred at the turn of the 19th and 20th centuries, we did not realize it. In fact, the supernova was hidden in dense gas and dust clouds near the center of the galaxy, and even with the technology of the time, we could have obtained a vast amount of valuable information. Needless to say, our technology has improved dramatically over the past 123 years, and that technology is being used to investigate supernovas that are difficult to observe in other galaxies. Supernovas appear as neutron stars or black holes covered in gas and dust clouds, just like other supernovas. Interestingly, these clouds continue to expand at an enormous speed of 15,000 kilometers per second. At present, the clouds have expanded to a size exceeding 2.5 light-years. This hypothesis may or may not be confirmed, depending on whether a similar presence is found near Earth. Located in the X-ray region, the constellation of Andromeda is one of the brightest celestial bodies, emitting very powerful radiation that can be likened to the Chernobyl disaster. As you may know, the radiation zone located 7,000 light-years away from the Sun is the remnant of a supernova. The gas cloud in the constellation of Andromeda, known as RxJ 0822-4300, is actually the core left over from a neutron star after a supernova explosion. After comparing the velocities of this object and the surrounding stars, it was found that it was moving at an exceptional speed compared to other objects that had been measured, with an estimated speed of 1,300 kilometers per second moving away from the point of the supernova explosion. The reason why neutron stars reach such speeds is unknown, but it could be a unique characteristic of the explosion. It is also important to consider that the explosion occurred about 5,000 years ago, and the acceleration may have decreased over time. How fast was it going at the beginning? The supernova SN 1054, which gave birth to the Crab Nebula, became famous for this reason. First, scientists discovered the Crab Nebula and then calculated that the supernova that created it exploded around the 11th century. Afterwards, scientists discovered a record of a bright star suddenly appearing in the same place where the Crab Nebula was discovered in ancient Chinese documents, which was a great triumph in astronomy. Behind this shining success, there was another quiet supernova. SN 1006 exploded 48 years before SN 1054 and was even brighter and better documented in historical records. While only the Chinese realized the significance of SN 1054. However, SN 1006 was recorded in documents from various regions of the Eurasian continent, including Switzerland, Egypt, and China. Arab astronomers reported that the celestial body shone brighter than Venus, while European monks claimed that the star not only changed in brightness, but also in size, expanding or contracting, and sometimes even disappearing completely. The explosion of SN 1006 occurred in this vicinity, and even after a millennium had passed, the diffusion rate of the gases released by the explosion was still remarkably high, at a speed of 9,000 kilometers per second. The power of the explosion must have been beyond imagination. There is another supernova that has expanded human knowledge of the universe, and that is SN 1572, which occurred in the Cassiopeia constellation in 1572. The history books of Europe and the Arab East contain detailed descriptions of this remarkable star. The name of this supernova comes from the famous Danish astronomer Tycho Brahe. However, he was not the first person in Europe to discover this supernova, nor was he the first to record its appearance in detail. But he studied stars in much greater detail than any other scholar in the world at that time. He succeeded in measuring the parallax of this celestial body, which was a significant accomplishment at the time. According to the observation methods at that time, Saturn was considered to be the farthest planet from the Sun or the Earth. However, through simple calculations, he discovered that this supernova was much farther away than the Moon or Saturn. In this way, humanity first became aware of how vast the universe is and how far stars are from us. There is another excellent discovery that has advanced astronomy. It was made by two contemporary British scientists, Thomas Digges and John Dee, who discovered the same nova. Using data from Tycho Brahe and their own measurements, they overturned the 1,000-year-old image of stars being located on celestial spheres, and speculated that stars would be spread throughout the universe. Perhaps no astronomical phenomenon has had such a significant impact on the development of scientific knowledge as Tycho Brahe's supernova. Furthermore, compared to the standard of the nova, there is nothing particularly exceptional about it. Scientists discovered that this celestial body was the result of a white dwarf star exploding in a close binary system. This is one of the mechanisms for supernova explosions, similar to when a massive and bright single star explodes at the end of its life. Another star forming a binary system was also discovered. This star, similar to the Sun, is surrounded by clouds formed by the explosion. Thank you for watching until the end. If you enjoyed the video, please don't forget to click the subscribe and like buttons and share the video on social media. Supermassive black hole is the largest known genius among scientists and probably the rarest celestial body. Supermassive black holes typically exist in one galaxy, but not in all galaxies. Hello everyone, here's where these supermassive black holes come from. Let's find out together, starting now. According to existing astronomy and physics, it is known that standard black holes appear when particularly bright and massive supernovas explode. Theoretically, the mass of these black holes ranges from 30 to 50 times that of the Sun, but in reality, there are many that are much lighter. Black holes with hundreds or thousands of times the mass of the Sun have not yet been discovered, and only a few candidates have been proposed. This is known as the intermediate mass black hole problem. The main character of this discussion is the supermassive black hole, which has a mass of tens of thousands to millions times that of the Sun. Its origin is one of the most interesting problems in astronomy and physics. In reality, there are no stars of this size, so where did they come from? The relationship between supermassive black holes and galaxies is also fascinating. These black holes are typically found in the center of galaxies, but the existence of galaxies without supermassive black holes is known. However, supermassive black holes without galaxies have not yet been confirmed. The formation of galaxies and supermassive black holes is a problem similar to the chicken and egg problem. Which came first, the supermassive black hole that gathered matter around it, or the galaxy that formed first and had a black hole at its center? There is still no consensus on this issue. So where did they come from? The biggest problem in the formation of supermassive black holes is that it is not enough for a massive amount of matter to gather at a single point. To increase the mass of a black hole by having a large amount of matter fall into its singularity, it must rotate very slowly. Otherwise, an accretion disk will form around the black hole, and that will be the end of it. Of course, it is possible that the matter in the surroundings could be consumed by a black hole, but it is not very common for it to become a supermassive black hole. To understand the most likely explanation for the formation of these supermassive black holes, we need to look back in time to the distant past, around 550 million years after the Big Bang, during a period known as the Dark Ages. During this time, the universe was filled with hydrogen and helium, and was not yet transparent enough for light to pass through. It is believed that the first stars began to shine during the end of the Dark Ages and the following cosmic dawn. As the first stars appeared, matter was consumed and transformed into starlight, gradually making the universe more transparent and bringing it closer to its current state. Generally, the universe during the Dark Ages was a cradle of a giant star, meaning it was a gas or dust cloud where new stars were born. The existing theory is that dark matter actively participated in this process. As dark matter gathered material through gravity and began to surround it, galaxies were formed in no time. At the center of this fence, the density of material is very high, and it is said that primitive stars, which weigh more than 20 times the mass of the Sun, were formed massively at this time. For various reasons, these stars seem to have been very unstable and began to collapse rapidly without exploding. When a supernova explosion occurs, it collapses and becomes a black hole or neutron star. Although it is only a tiny fraction of the matter that was concentrated in the building, when a primitive star collapses, it becomes a black hole in its entirety. Then, these black holes merge, creating a supermassive black hole. Some modifications have been added to the theory through recent research. Many scientists currently believe that there was no merger between black holes, but instead, a single primitive star with a vast mass ranging from tens of thousands to millions of times the mass of the Sun was formed in the galaxy. It is difficult to imagine what process might have taken place since such stars do not exist in the universe today. Perhaps these primitive stars began to collapse silently for only a few thousand years. Although this hypothesis seems to make sense, there are several unexplained phenomena. One of them is, as mentioned earlier, that most of the supermassive black holes have masses of hundreds of millions or billions of times that of the Sun, not just thousands of times. For a black hole to become this massive, according to the hypothesis of a collapsing primitive star, it must absorb an enormous amount of matter in a very short astronomical period, many millions of times its own mass. However, in reality, black holes do not continue to grow infinitely because the surrounding matter is almost exhausted. The remaining matter becomes part of the accretion disk and does not fall into the black hole. The first black hole was hypothesized to solve problems with existing theories, and scientists attempted to use new theories, such as the primitive black hole theory. The key point of this theory is that some black holes were not originally related to stars and never were stars. These black holes are believed to have formed shortly after the Big Bang. At that time, the universe was very hot, dense, and rapidly expanding. In this situation, the space itself was moving in a different way from today. It is believed that the unevenness of space, or pockets of space distortion, may have compressed matter and caused collapse. There were various masses in these primordial black holes. The smallest black hole was only about the size of the Planck mass, which is very small at 1/1,000,000 of a kilogram. This type of black hole may have collapsed quickly and no longer exists. On the other hand, there is a possibility that the largest black hole was thousands of times the mass of the Sun. This is the type of black hole that we find most interesting. These primordial black holes had an incredible density of matter. There is a possibility that it absorbed a massive amount of matter in a short period of time and grew to a size close to that of a supermassive black hole, which then gathered surrounding matter and facilitated the formation of the first galaxies. Currently, no new primitive black holes, supermassive black holes, or new galaxies are formed in the universe due to changes in matter density. However, there are weaknesses in the theory. For example, in a very compact universe, a young supermassive black hole may have grown rapidly, but it is unclear why it did not absorb all or most of the matter. Additionally, it is unclear why the universe entered a dark age in this scenario. Matter did not just scatter throughout the universe, but rather it was originally gathered in galaxies. However, if we assume that the natural formation of supermassive black holes was possible not only immediately after the Big Bang but also during the following 500 million years, we can solve this problem. Currently, there is no hypothesis that can explain why there are no supermassive black holes present in all galaxies. It is possible to guess that this could be due to a lack of matter in dwarf galaxies, but even in the Triangulum galaxy, the largest in our local group, there are no supermassive black holes. Therefore, a theory that can explain all of these phenomena will emerge in the future. Thank you for watching until the end. I hope you enjoyed the video. If you did, please subscribe to the channel, leave a like, and share the video on social media to help promote science and space.
According to the widely accepted theory, approximately 13.8 billion years ago, a Big Bang occurred that gave rise to everything we know now. It is believed that at that moment our entire universe was born, which subsequently formed into what we see today. However, before the Big Bang, there may have been nothing or something that we cannot even imagine. We will try to understand what was before the Big Bang. The Big Bang is a widely accepted cosmological model that describes the early development of the universe, beginning with the expansion of the universe, which was in a singular state before that. As for this singular state, it is sometimes characterized as a cosmological singularity. It was the state of the universe at the initial moment of the Big Bang, which was characterized by infinite density and temperature of matter. To understand what happened before the Big Bang, we turn to some theories that directly relate to the explosion itself. According to one of them, at the moment of the Big Bang, the universe could have been extremely small. It could literally have been a tiny point. Some scientists believe that everything we have in the observed universe today, this sphere with a diameter of about 93 billion light years, containing at least 2 trillion galaxies, was a tiny point. All today's galaxies were as if squeezed into a space smaller than centimeters in diameter. However, this is not the only version. According to another theory, the universe could already be infinitely huge beyond the observable universe. There may be much that we simply cannot see because it is physically impossible. Therefore, it is possible that the universe was tiny or infinitely large during the Big Bang, because there is no way to see what remains beyond our visibility. The essence is that space itself is expanding, so everything that was beyond the tiny point from which the universe was born will remain outside of our reach. Yet, what existed before the Big Bang is undoubtedly one of the most global questions that people have been searching for many years. In fact, there is no one answer, and probably cannot be one because we simply cannot fully understand it at present. Therefore, there are only various theories describing possible processes that occurred before the Big Bang. For example, Stephen Hawking believed that there was absolutely nothing before the Big Bang. He said that if we rewind time by 13.8 billion years, the entire universe would be represented by a single atom. According to his words, if the universe is expanding as we move forward in time, then if in theory we could reverse time, it would start to contract and compress, which should not be confused with technological singularity. Inside this very small, massively dense spot of heat and energy, the laws of physics and time, as we know them, ceased to function. In other words, time, as we understand it, literally did not exist until the universe began to expand. There's also a completely opposite version, according to which, before the Big Bang, the universe was an infinite space made of dense material, which remained in a stable state until something disrupted it. When this dense space lost its stability, a big explosion happened, which was of a super-dense universe. It was possibly controlled by quantum mechanics, and after the big explosion, classical physics became the main driver of the universe's evolution. This theory explains the existence of space before the big explosion, but what about time? According to one point of view, time did not exist before the big explosion. Neither did space. However, in 2018, British cosmologists from Oxford University, led by Professor David Sloan, conducted calculations. The calculations showed that space and time did exist before the universe was born. David Sloan said, "We are not introducing any new concepts or changing the theory of relativity, just the interpretation of some of its postulates. Our calculations show that the Big Bang was not the beginning of time, but just a change in the orientation of space. In other words, it was space that broke, not physics." Elephant and his colleagues came to this conclusion while trying to find an answer to one of the most important questions in history: what the universe looked like in the first moment after the Big Bang and how it appeared before the cataclysm that gave rise to everything Today, as scientists explain, there are two approaches to this problem. For example, cosmologists believe that the universe was born from a singularity that began to rapidly expand in the first moments after the Big Bang. However, astrophysicists believe that the birth of our universe was preceded by the death of a progenitor, which likely occurred as part of the so-called Big Bang. Either way, both of these versions are almost impossible to prove. If we turn to the first theory, the very existence of some form of space-time before the Big Bang raises a multitude of almost insoluble questions. For example, it is not clear how this form could have given rise to an energetically pure and new modern universe. Another problem is that at present, cosmologists cannot even speculate about what this old world and old universe looked like. The issue is that the theory of relativity ceases to work at extremely high energies. The energies characteristic of the Big Bang and the singularity that created it have led scientists to debate what laws govern the universe's existence in the first moment of its new and final seconds of its old life, if it existed at all. Many cosmologists and astrophysicists, including the aforementioned Stephen Hawking, prefer to sidestep this question and do not assume that time did not exist before the Big Bang. Therefore, the problem is meaningless. However, David's team proposed a new interpretation of this mystery that resolves the question of the old universe's existence in an original way, without violating Einstein's postulates or introducing any new complex entities, such as strings or quantum loops. They focused on one simple thing. While inside the universe, we cannot precisely measure its dimensions and compare it to something beyond its boundaries. Therefore, all the quantities and phenomena described by the general theory of relativity and other cosmological theories are relative. The notes that this is a simple idea that allows scientists to circumvent practically all of the unsolvable problems associated with infinite energy density and the curvature of space, which cannot be explained within the framework of classical Einsteinian theory and the space-time structures associated with it. Guided by this idea, scientists have built a computer model of a dimensionless universe and studied what the starting point of the Big Bang looks like. It turned out not to be a singularity, but a different structure, which the elephant and his colleagues called the II point. In contrast to the Big Bang's fabric of spacetime, the fabric of spacetime does not cease to exist after its birth. Rather, it becomes mirrored. In other words, before its birth, as calculations by British researchers show, spacetime simply becomes mirror-like. In other words, before the birth of the universe, time flowed in the opposite direction, and space was oriented and represented somewhat differently. According to scientists, These transformations do not contradict the theory of relativity and do not affect matter itself. Essentially, only the map of its distribution changes, not its internal content. The elephant's innovative theory explains not only the principles of the operation and existence of time and space before the Big Bang, but also the absence of antimatter in the universe, as well as some other peculiarities that scientists are currently debating. The next theory, the Big Bounce, partially resembles the previous one. The theory suggests that a small explosion, or rather a big bounce, contributed to the birth of the universe, caused by a peculiar interaction between the old and new universe a long time ago. In medieval India, some religious philosophers taught that the universe undergoes an infinite cycle of creation and destruction, developing from undifferentiated mass into a complex reality before destroying itself and starting over. Some modern scientists have arrived at this same idea with striking parallels, believing that instead of a Big Bang, the universe expands and contracts in a cycle, bouncing back each time it contracts to a certain size. The theory of the Big Bounce is partially similar to the previous one. According to the theory of the Big Bounce, each cycle starts with a universe that is not as small and smooth as the Singularity. It gradually expands and becomes lumpy and deformed over time. Eventually, it reaches a point where it begins to break down and gradually smooths out, decreasing in size until it reaches its initial point. In this way, the Big Bang is like the beginning of the expansion of a new universe. Specifically, it is an explosion of singularity from nothing. In other words, the Big Bounce theory suggests that our universe is constantly being refreshed by these cycles. This means that before everything appeared, there was simply another universe that had reached the final stage of its cycle and had compressed to its original size, giving birth to the new universe that we can see in the observable universe, In any case, whether it was a Big Bang or a Big Bounce, the question of what existed before our current universe remains open. None of the above theories is 100% accurate. They are all just theories. Perhaps one of them is correct, or perhaps they are all far from the truth. Maybe there was nothing before the Big Bang. Perhaps there was a whole universe, or even time and space, or maybe there existed an entire sea of universes, each with their own laws and physical properties. Perhaps we will never be able to answer the question of what existed before the Big Bang. It is likely one of those questions that has no answer, at least not yet. However, it is not impossible that in the future, science will advance to such an extent that it will be able to answer this question and provide a complete picture of what happened before the beginning of the universe. It is also possible that future generations of scientists will delve even deeper into this topic and find answers to even more complex metaphysical questions. For now, each of us can only speculate and choose the versions that resonate with us. Please leave your thoughts in the comments section, and if you found this interesting,
Andromeda Galaxy is perhaps the most well-known galaxy to the general public, excluding the galaxy we live in. This galaxy is frequently featured in science fiction works more than any other galaxy. This is not surprising because it is the largest galaxy closest to Earth. It takes about 2.5 million light-years to reach the Andromeda Galaxy, which is a surprising number for us, but a trivial distance in terms of the universe. The Andromeda Galaxy is one of the few galaxies visible to the naked eye. Therefore, its existence has been known for a long time. However, its structure cannot be seen due to the fact that it is very far away. Therefore, in medieval literature, it was depicted as a small cloud floating in the night sky. Even with the invention of telescopes, this problem could not be solved. Early telescopes were very primitive, so individual stars in the Andromeda Galaxy could not be distinguished. Some nebulae were discovered in the Milky Way, and the protagonist of this video was also considered one of those nebulae. The original name given to this galaxy was the Andromeda Nebula, due to such circumstances. In 1855, scientists noticed an explosion that occurred in the Andromeda Galaxy. It was probably a very bright supernova, but it was considered simply the new star starting to burn. The fact that a star begins to burn inside a cradle of stars, known as a nebula, was already known at that time. Therefore, this distant galaxy is constantly expanding. The misconception that common nebulae are impossible to understand seems to be deepening. It was only towards the end of the 19th century, when the telescope had been improved, that we were able to barely recognize the structures of whirlpool arms in the Andromeda galaxy and bright nebulae. This was also around the time when a faint voice first suggested that what we were building was not a nebula, but another galaxy, like the Milky Way. However, at the time, the single galaxy model was dominant, and most scientists thought that the Milky Way was the entire universe. It should be noted that in the mid-19th century, there was a claim that the Magellanic Clouds were other galaxies, but many people denied it for the same reasons. To defend the scientists of the time, their reaction was not simply due to rigid thinking. At the time, astronomers did not have the ability to measure distances to distant celestial bodies as accurately as we do now. For example, in the case of the Andromeda galaxy, various researchers estimated the distance to be closer to Polaris than the North Pole. Finally, in 1923, the great Edwin Hubble succeeded in using the latest telescope of the time to discover several Cepheid variables in the Andromeda galaxy. Cepheid variables are a type of bright yellow variable star that has the characteristic of always changing its brightness with the same period, even though it is the same star. There is a formula for deriving the distance to a star by substituting the apparent brightness and actual brightness of the star. Cepheid variables are the easiest type of variable star to improve. When Hubble improved the distance to the Cepheid variables in the Andromeda galaxy, he realized that it couldn't exist in the Galaxy 1 group. Even the boldest of the past calculations turned out to be wrong. The distance was over 2.5 million light-years. As a result, the scale of the universe known to humankind expanded enormously. Other celestial bodies, such as the Magellanic Clouds, were also confirmed to exist beyond our galaxy by Hubble. Andromeda galaxy was the first to be identified as a galaxy. As research progressed, we learned many new and interesting facts about the Andromeda galaxy. For example, we learned that this galaxy is much larger than our own Milky Way, with a diameter of over 45,000 parsecs and containing at least first-magnitude stars. The largest galaxy in our local group is the Andromeda galaxy, followed by the Milky Way. Like the galaxy, Andromeda has a distinct disk and several spiral arms. Most of the countless stars that belong to the Andromeda galaxy are included in this disk. The center of the galaxy contains the galactic nucleus. Interestingly, the galactic nucleus appears to be double. Even in photographs, two distinct structures, one large and one small, separated by about 5 light-years, can be clearly identified. The structure on the dimmer side is called P2, and it is believed to be the true center of the Andromeda galaxy. There is a supermassive black hole at this location, but its mass has not yet been fully determined. Estimates suggest that it may be tens of millions or even billions of times more massive than the Sun. For reference, the supermassive black hole at the center of our own Milky Way galaxy has a mass of only about 4.3 million suns. The larger and brighter structure, located slightly away from the center of the galaxy, is called P1. However, it is currently unclear what this structure is. Perhaps, from an astronomical perspective, relatively recently, the Andromeda galaxy may have consumed another galaxy, and that galaxy has not yet been completely digested. If that is the case, P1 may be the remnant of the disrupted galaxy. Even those who have never heard of it before may not know that galaxies sometimes swallow other galaxies. Andromeda is particularly interesting in this regard, as one of the highlights is the globular cluster called Mayall-2, which is located 130,000 light-years away from the galaxy's center. Mayall-2, discovered in 1953, is known as the brightest star cluster in our local galaxy group. Usually, globular clusters are composed of very old, dim stars that were born at a similar time. However, Mayall-2 is more interesting because it contains a variety of age groups of stars, including some that are much younger. Stars with a high metal content also exist. There probably isn't any life in the Ama star cluster. In the globular cluster, stars are always in planetary system shapes because they are densely packed. Nevertheless, rare shapes are clearly visible in the Andromeda galaxy that are smaller than formal galaxies, including dwarf galaxies. These structures have a spherical shape, a very large radius, and contain a large number of stars. Perhaps, like Mayway 2, they are remnants of swallowed galaxies. In 1999, scientists recorded an anomalous phenomenon called PA99 in the Andromeda galaxy. During this process, the fusion of an old red giant star, one of the observed low-mass celestial bodies, was caused. There are several interpretations for this phenomenon. Some scientists believe that this mysterious celestial body could be a planet with a mass of about 6 times that of Jupiter. If their view is correct, this would be the first extraterrestrial planet discovered in another galaxy. However, other astronomers argue that the object involved in this phenomenon is not a planet, but a small star. In any case, there will be many planets in the Andromeda galaxy, including those similar to Earth. In this galaxy, there are very old stars and very young stars, and the stars are clearly divided into 3 generations, accounting for most of the population of the galaxy when combined. Scientists paid attention to this point immediately. The age of these stars ranges from 10 billion to 11 billion years, respectively. Of course, what we are most interested in is the second star that corresponds to the Sun. There are enough of such stars remaining in the Andromeda galaxy, so surely many extraterrestrials will be discovered. If there are any intelligent beings or humans that still exist in the Andromeda galaxy in tens of billions of years, they may come to meet us without even having to show off their technological skills. However, the problem is that the 2 galaxies are slowly approaching each other and will collide and merge 4 billion years from now to become one galaxy. But there won't be any major cataclysms on the scale of the Earth. The distance between the stars is quite wide, and even if aliens interfere between us and Proxima Centauri, there won't be any significant harm. Please subscribe to our channel and press like, and don't forget to share this video on social media. Space is a place of frighteningly vast distances. Just the thought that incredibly fast light takes 13 billion years to reach us from some galaxy can make one feel uneasy. But if we focus on the positive, the distance between us and Mars, just a dozen or so light minutes away, seems like a hop in space terms. And there are times when our cosmic neighbors seem incredibly close. Even the 4 light years to Alpha Centauri don't look scary compared to distant galaxies. It's insanely close, and there's no doubt that humanity will eventually reach our solar system's cosmic neighbors. But who are they, apart from Alpha Centauri? Few would name the stars neighboring our Sun, but don't worry, we'll cover that in the next couple of minutes, and also estimate how far away they are. Before we talk about the chances of finding life on our cosmic neighbors, let's first discuss how scientists can determine which stars in the sky are close to us and which are far away, and how they can be sure they're not mistaken. The concept of a parsec, which you've probably heard of from science fiction, is a unit of measurement that was introduced thanks to the use of parallax. The prefix par means parallel, and SEC stands for sector of gas, which is, of course, a joke. The actual meaning of acer is arcsecond, thanks to which we can use Apple devices to experience parallax in a simplified way. In fact, with the release of the iPhone 7, Apple introduced a new type of wallpaper that creates the illusion of depth when the phone is moved, simulating the effect of parallax. The term symbolizes the change in the apparent position of an object depending on the position of the observer. Try holding up your finger and closing your left eye while looking at it with your right eye. Then, quickly close your right eye and open your left eye. You should see your finger appear to jump to the side. This is the same principle that scientists use to measure the distance to nearby stars. If you move your finger closer to your eyes and repeat the procedure, you will see that it has shifted more than before. If you draw imaginary lines to your finger, you will get a triangle, one side of which you know well the distance between your eyes. The two angles at which the eyes are looking at the finger are also known, and finding the length of the remaining side, which will be the distance to the finger, is a matter of time. And now, put reason and great scientists, whole generations of hard work and huge formulas on this scheme, and you will get a method according to which the distance to the objects was calculated with excellent accuracy. Distances to thousands of stars, and even to the planets of our solar system, as well as the Sun itself, were initially determined using the parallax method. This method is based on observing how their position changes against more distant objects when viewed from different points or as the Earth rotates. It is not difficult to guess that objects that are too far away cannot be calculated using the parallax method, since we are limited by the diameter of the Earth. Even when viewed from both ends of the planet or during a complete rotation, the displacement of distant stars will be negligible. Other methods are used for those objects. But what we are interested in are the nearest neighbors of the solar system, which can be reached by simple parallax and later refined using more accurate methods. It should be noted that even 10 light-years is a huge distance. The distance is too great for us to judge the number of neighboring stars definitively. In order to determine the distance to something, you need to see it first, and among the stars, there are very dim brown dwarfs. Therefore, the question of a precise number of our nearest neighbors remains open at the moment. With brown dwarfs taken into account, it is estimated that there are 14 large neighboring stars at a distance of 10 light-years from our solar system. Let's start our story with a tiny red dwarf, standing at a height of 154. If we were to send light directly towards it, it would take about 9 69/100 years to reach it, which is amazing. At least we know that this star is still alive, unlike some fairy dish that sent its light to us about 6,000 years ago. We see it as it was when the ancient Egyptians were building the Pyramid of Cheops, so what can we say about row 154? Not much. It's a very typical star, as red dwarfs make up more than half of the stars in the galaxy. Row 154 is 5 times smaller than the Sun in mass and 300 times dimmer in brightness, and is located in the constellation Sagittarius. Despite its proximity to Earth, it cannot be seen with the naked eye. Interestingly, 154 is characterized by intense X-ray radiation, which is greater than that of the Sun. This can be explained by the star's relative youth, as it is less than 1 billion years old. At the time of its formation, there were already algae on Earth. However, due to its proximity to the Sun, the star falls into the first category of astronomers' attention. Searching for planets around stars is incredibly difficult because they are very dim compared to stars, and 154's height itself is not particularly bright, plus it is close. At one point, one of NASA's missions was very interested in studying this star because theoretically, we could find a planet there that is 3 times the size of Earth. However, unfortunately, funding was not obtained and there wasn't much reason for the planet, which would need to have Earth-like conditions, to be located 4 times closer to its star than Mercury is to the Sun. Its orbit would be blocked, and the hypothetical Earth-like planet around 154 would always be facing one side, receiving too much X-ray radiation and too little red light for photosynthesis. Therefore, even theoretically, finding habitable planets around red dwarfs like 154 is extremely challenging. We don't really have anything to do with our lives, but our theories are still based on the Earth, so let's talk about Sirius instead. You don't need to get to know it twice, it's the brightest star in the night sky. If you put the Sun and Sirius at the same distance, Sirius will be 25 times brighter than our star. However, we shouldn't be deceived, there are much brighter stars in space in absolute terms than Sirius. For example, Rigel's luminosity is about 120,000 times higher than the Sun's. If you were to switch places between Rigel and Sirius in the night sky, Rigel would shine like a third of the moon. Nevertheless, Sirius is still a bright star. It is roughly twice as heavy as the Sun and almost twice as large as the Earth, so it has been known to humans since ancient times. It was worshipped in ancient Egypt, Babylon, and Greece, and that's where it all started. The name Sirius, which translates as shining, also refers to its location in the constellation Canis Major. According to legend, Sirius is the dog of Orion. The Romans even translated the star's name as Canicula, meaning little dog, because its morning visibility coincided with hot days, which later became known as dog days thanks to the star. Now, the word vacation is associated with the meaning of the word canicula, and school children all over the planet are happy to have it. What is this neighbor, located just 8.5 light years away from us? Sirius is a great star of spectral class A1, and it has a tiny white dwarf companion, Sirius B, which astronomers jokingly call the puppy. This is really the case because Sirius B is 360 times dimmer than the Sun. However, it should be noted that there are much brighter stars in space than Sirius in absolute terms. Puppy is still well-fed, and in terms of mass, it is not inferior to our Sun, being one of the largest white dwarfs. However, this does not make the Sirius system particularly unique. There is every reason to believe that systems with two stars are more common in space than single stars, and our introverted Sun is a typical resident of the universe. If there is potential for life in this system from our point of view, then a terrestrial planet and conditions for liquid water would need to be located far from Sirius, as far as Jupiter is from the Sun, which is 4 times farther than the Earth is now. The year would last about 6 years, which is not the worst thing, but the worst is that Sirius emits much more ultraviolet radiation than the Sun. It is possible to forget, and therefore there are questions about ordinary free oxygen, and the weight of the Sirius puppy will also affect the orbit, and therefore the stability of conditions on the planet. In general, everything is very bad, and from the point of view of real research, even worse. Sirius is very bright, and despite its proximity to the Sun, it is very difficult to find a planet near it. Current scientific achievements allow us, in theory, to find only a planet with a mass of 510 Jupiters at a distance of 25 times farther than the Earth from the Sun. In 2008, such a test was conducted, and the result was predictable negative. Some scientists still believe that Sirius is not a binary triple star, and we still cannot conclusively refute them. Hubble tried to find another brown dwarf or some huge Jupiter, but he could not, although the theoretical calculations as a whole allow for the possibility of stable orbits within the system. Perhaps in the near future, we will study Sirius better, as it slowly approaches the Earth, and in the next few tens of thousands of years, it will shine even brighter. However, the distance will increase again, but we can say for sure that for another couple of 100,000 years, Sirius will be the brightest star in the sky, unlike our next neighbors. Wolf 359 is insanely dim red dwarf. It is closer to us than Sirius and is located 7.8 light-years from the Sun, but much dimmer. It is impossible to see a planet with the naked eye in the sky. If we were to switch our Sun to Wolf 359, then Earth's round shape would disappear. Without a telescope, it wouldn't be visible, and during the day it would be 10 times brighter than during a full moon on Wolfie 359. We wouldn't have stopped if it weren't for its high cavity in 2 directions. The first reason is the potential presence of 2 exoplanets. In 2019, a team of astronomers led by Meg Kotlamy published a study announcing 2 candidates for exoplanets in the Wolf 359 system. The planet is 20 to 40 times larger than Earth and rotates twice as far away. The second planet is allegedly only 4 times larger than our planet and is located close to the star, close enough to allow the possibility of life. However, scientists quickly cooled their enthusiasm, as the amount of radiation that this hypothetical planet would receive would be many times greater than Earth's, making the existence of life unlikely. The planets themselves are still only candidates, as direct observation and confirmation of their existence is difficult. But scientists remain interested in Wolf 359 for 2 reasons. First, this star is located near the plane of the ecliptic, which means that if you were to look at the Sun from the Wolf 359 system, all the planets of the solar system would be visible at once. Hypothetically, if advanced aliens have scattered probes throughout the universe for scanning, then a probe on Wolfie 359 could easily discover the existence of Earth. And, in turn, by observing Wolfie 359, we may find a hypothetical probe studying us. Of course, these searches have not led to anything yet. Much more productive to scientists is the legendary star Barnard, another neighbor of our Sun. It is the second closest object of its type to us, or the fourth if you count Alpha Centauri, which is a triple star system. Firstly, it is important to know how fast Barnard's star is. It approaches us so quickly that it creates the impression that it owed the Sun 100 kilometers. Except for the Sun itself, it is the fastest star in the sky, flying towards us at a speed of 110 kilometers per second. And if now Barnard's star is somewhere 6 light years away, then in 11,000 years of our era, the distance will be reduced by a third and will already be equal to 3 whole light years. By cosmic standards, this is insanely fast. We see it as it was at the time when the construction of the Pyramid of Khufu in ancient Egypt had not yet begun. There is not much interesting to say about its height of 154, as it is a very typical star, since red dwarfs make up more than half of the stars in the galaxy. Its height is 5 times smaller than that of the Sun, and its brightness is 300 times less. It is located in the constellation Sagittarius, and, despite its proximity to Earth, it cannot be seen with the naked eye. The only notable thing about its height of 154 is the incredibly intense X-ray radiation it emits, which is more than that of the Sun. This can be explained by the star's relative youth, which is less than 1 billion years old. When it was formed, there were already algae on Earth, but because of its proximity to the Sun, the star is among the brightest in the sky. In addition, it has X-ray radiation and is a bit lazy and slow-moving old guy, but this doesn't negate the fact that the temperature on the surface of this star, belonging to the red dwarf Barnard, is almost 3,000 degrees. It's worth respecting at least because, due to its proximity, it has become almost a standard in studying stars of this type. It's quite difficult to study them because they are dim and heavy, but it's slightly easier to search for planets than it used to be. Peter van de Kamp announced the discovery of 2 planets orbiting Barnard's star in 1960. The first planet was similar in mass to Jupiter, while the second was only half as large. However, Peter couldn't find confirmation of his discovery, even though he tried very hard. The Hubble telescope helped to clarify that planets with a mass greater than 5 Earths cannot orbit Barnard's star. It seemed that there was no hope left, but in 2018, an international team of astronomers announced that they had found a planet about 3 times the size of Earth, orbiting Barnard's star at more than twice the distance that Earth orbits the Sun. However, despite the accuracy of the calculations, Barnard's planet B still remains a candidate, although its existence was also confirmed in 2021. Furthermore, most astronomers give a 90% chance of potential life on a potential exoplanet. However, even if the planet is twice as close to its star as Earth is to the Sun, it will receive extremely little heat due to the coolness of the star. Sometimes the temperature on a hypothetical exoplanet is unlikely to be higher than -170 degrees. In general, the prospects for life are bleak with the other neighbors of Earth that have potential for life. However, the mighty system of Alpha Centauri, consisting of 3 stars, comes onto the scene, located about 4 light years away from the Sun. 2 of the 3 stars in Alpha Centauri A and Alpha Centauri B, are of great interest as they are very similar to our Sun. Alpha Centauri A shines 1.5 times brighter and is slightly larger than our Sun, while Alpha Centauri B is slightly smaller than the Sun and shines half as much. The entire Alpha Centauri system is slightly older than the Sun, and visually the 2 large stars merge into one when observed from Earth. This is not surprising since they orbit each other at an average distance of only 24 times the distance between the Earth and the Sun. If the Sun were replaced with another star, in moments of closest approach, the star would be separated by a distance equal to that between the Sun and Saturn. The third member of the star system, Proxima Centauri, is a true runt. It is only 1.5 times larger than Jupiter and is a red dwarf. Even Barnard's star looks like a giant against its background. Proxima Centauri is also actively studied, but it is the two older sisters, Alpha Centauri A and B, that really excite scientists. They have been studied extensively, even peering into their atmospheres and finding similarities to the Sun, and conducting some of the most precise calculations of possible planetary and life presence. Many simulations were conducted and they conclusively ruled out the presence of giant planets. This is not surprising since two of the three stars are so close together, and Jupiter would face a sad fate between their gravitational influence. However, simulations showed that both stars have a so-called habitable zone, which is an orbit where theoretically stable planets with liquid water can exist. Unfortunately, due to the brightness of the stars, even taking into account the insane proximity of the Alpha Centauri system, it is difficult to say anything. In 2012, European astronomers claimed to have found an exoplanet around Alpha Centauri b, but its existence was disproved 3 years later. The situation is slightly better for the larger star, Alpha Centauri A. In February 2021, a candidate exoplanet was found there that is remarkably similar in size and orbit to Earth. It will be verified by the James Webb Telescope, and we still have yet to learn the outcome. However, the true king in this scenario is quite unexpected. In the search for life, the collapse of the Proxima Centauri system is not surprising. On the one hand, as we mentioned before, it is slightly easier to find planets around dim stars. However, the exoplanet discovered there in 2016 is astonishing. It is also almost identical in size to Earth, but its year lasts only 11 days, which means it is much closer to the star. Considering that Proxima Centauri is a dim star, this is an ideal combination of factors. The exoplanet candidate receives 65% of the Earth's warmth, which theoretically opens the doors to the existence of liquid water. However, more recent calculations are less optimistic due to the proximity to the star. Potential Earth 20 receives an indecent amount of radiation, and since Proxima Centauri is a red dwarf, it periodically experiences powerful flares. For example, in 2017, a flare was recorded that according to scientists' data would have certainly killed the planet. All your life on a planet, even if one existed, is not so bad. There are several candidates for exoplanets in the Alpha Centauri system, some of which are also in the habitable zone. There is hope that the James Webb Telescope will help confirm or refute this data, but of course, Alpha Centauri is the main candidate for all organizations that aim for interstellar travel. There is, of course, the Project Daedalus, which aimed at the Barnard star, but this is rather an exception because scientists mostly dream about Alpha Centauri, and here dreams come up against harsh reality. Humanity has exactly one spacecraft that shows signs of life outside the solar system, Voyager 1, which was launched in 1977 and was actually designed for 5 years. It miraculously stayed on track and in 2012 entered interstellar space, but even it will not approach another star for 40,000 years, although it is not about Alpha Centauri. Voyager is heading in a different direction, as are the New Horizons and Pioneer 10 spacecraft. Their missions, like Voyager, were mainly focused on the inner part of the solar system. Specifically, nobody has sent anything to other stars yet. However, if Voyager had been turned around at the same speed and sent to Proxima Centauri, it would have reached it in 76,000 years. And mind you, this is one of the fastest spacecrafts in human history. Of course, there is also the Helios 2 probe, which was accelerated using the gravitational pull of the Sun to an indecent speed of 240,000 kilometers per hour. But even with this speed, it would take 19,000 years to travel 4 light years. There was a prototype electromagnetic engine from NASA that went even faster during testing. But even for it, it would take 13,000 years to fly to Proxima Centauri. Nuclear and thermonuclear reactor projects do not help much. They are either too dangerous, too expensive, or too slow. The laser sail technology is considered the most promising in the near future. According to this technology, a sail is deployed around the ship, just like in the old days, and solar radiation accelerates it for greater speed. This sail is pushed by lasers, and according to Robert Frisby's calculations, it could reach Alpha Centauri in 12 years. However, for this to happen, its diameter must be a paltry 320 kilometers, and the useful payload would be a canned food tin and a tennis racket. And there is also antimatter, engines powered by which can be incredibly efficient. However, the production of 1 gram of antimatter would cost several $1 trillion. Overall, the situation with interstellar travel is very sad. Either the necessary technologies don't exist yet, or they are just concepts, or they are too expensive, considering that interstellar travel has little practical value. It's clear that most scientists are focused on solving everyday problems. The bright spot on this background and hope for our generation is the Dragonfly project, which involves sending a very tiny sailcraft to Alpha Centauri. The goal of the project is to reach the star within 1 generation, but for now, it's just a concept. Strictly speaking, we need to study our own solar system better, and until we finally figure out Mars and potentially habitable moons of Jupiter, looking towards Sirius and Barnard star is premature.
Sometimes it seems that our planet is huge, and we are just tiny particles, mere specks against its colossal dimensions. Indeed, in the scale of the universe, Earth appears to be a giant, but it is actually insignificant and small. We often talk about distant galaxies and the edge of the universe to understand the place our planet occupies in this world. However, what if we take a journey not billions of light years away, as we have become accustomed to, but instead stay within the confines of our solar system? It might seem boring, but there's still much we don't know about the planets we were taught about in school and the countries whose names we heard. Leave your earthly problems behind and look at the night sky, where the moon stands out prominently. The moon, an unchanging natural satellite of Earth, has been visited by 12 American astronauts. The first, as you know, was Neil Armstrong, who set foot on the moon in 1969. The last person to set foot on the moon was Harrison Schmitt in 1972. 51 years have passed since then. However, despite that, the moon remembers everything. It is distant from the Earth at a distance of 384,400 km, but in the scale of the universe, it is not such a great distance. However, in human perception, this journey appears to be very, very long. It is quite possible that a new journey to the moon will happen very soon. In May 2024, a manned lunar flyby is planned as part of the Artemis 2 mission, and in 2025, there are plans to land humans on its surface during the Artemis 3 mission. Who knows, perhaps after that, we will look at the moon with a completely different perspective. Let's fly away from Earth a little further. There's something more interesting waiting for us there, Venus. The planet named after the Roman goddess of beauty truly mesmerizes with its hostile and deadly beauty. Due to its reflecting sunlight clouds, it is also the brightest planet in our solar system. So it is impossible not to notice it. It has several names: the morning star, the evening star, and the evil twin of Earth. But why the evil twin? Judge for yourself, as the sizes of both planets are indeed similar. However, while Earth is a comfortable planet for life, Venus, on the contrary, is harsh. The atmospheric layer of Venus is dominated by carbon dioxide gas, and the clouds, which could be mistaken for earthly ones, are made of sulfuric acid. Life forms as we know them wouldn't survive. And that's not the only reason why Venus can be considered an absolute hell. It's incredibly hot on Venus, somewhere around 500 degrees Celsius. Not a pleasant temperature, I must say. And of course, if we were to land on the surface of Venus, we would simply turn into a pancake. It's all due to the deadly gravity for human beings. Truly, it is the evil twin of Earth, deadly beautiful. Global warming here is without exaggeration taken to the extreme. It's quite likely that things were not always like this, and Venus was not as menacing. There's a theory that over time, Earth may end up looking the same with a threatening atmosphere. Who knows, perhaps everything is indeed like that, and maybe a different fate awaits Earth, similar to Venus. Closest to the Sun is Mercury, and it is also an extremely inhospitable planet. During the day, the temperature there is around 430 degrees Celsius. At night, it drops to 190 degrees, horrifying temperature fluctuations. The terrain of Mercury is characterized by numerous irregularities, which indicate the turbulent times it has endured. For its size, the planet is quite massive, and its gravitational force is truly enormous. Perhaps, at some point, the planet was larger, but due to a collision with another planet during its early stages of existence, it reduced in size. Who knows, if that hadn't happened, Mercury could look completely different now. Yes, the cosmos is cruel and not everyone's destined to remain intact or even survive. Our main star, the Sun, the source of life and death. It is just as deadly in its magnificence as Venus. Thanks to the Sun, life exists on our planet. However, it can also destroy us. Our ancestors were aware of the tremendous power of the Sun and its influence on us. That's why, in ancient beliefs, there was always a sun god, such as Helios in ancient Greece or Re in ancient Egypt. The Incas worshipped the sun, and the Aztecs feared it. The surface of the Sun is very hot. The temperature reaches 572 Kelvin. In the inner layers, it's even orders of magnitude higher, and it's terrifying to imagine that figure. Just imagine the power of the nuclear reactions happening there when you go out to bask in the sun on a spring day. Remember how deadly the sun is and how many nuclear reactions are occurring on it at that very moment. Prominences, which are loops that form above the surface, are held in place by the sun's magnetic field. Even 10 million volcanoes would barely produce as much energy as a single one of those loops generates. Sunspots also form there, and they stand out due to their black color. Their temperature is an order of magnitude lower than the surrounding areas. However, the sun has great power, but nothing lasts forever, and our main star is no exception. Sooner or later, the sun will reach its point of slow fading and perish, and that means the same fate awaits our home planet, and we will continue to acquaint you with these facts. Humanity is not only interested in what will happen in the future, but also in what has happened in the past. Take comets, for example. They also carry tremendous power within them. Our planet has not encountered comets on its path for a long time. However, according to some specialists, one of them could have collided with the Earth and contributed to the emergence of life by providing us with water. And that's precisely why Earth could have become the way we know it now. This allowed the human race to come into existence. But imagine what would have happened if a comet collided with our planet now. It would mean the end of humanity, at least on Earth. Perhaps, if such an event occurred, some people would start searching for a new home on another planet in giant space arcs like in science fiction novels. But for now, we haven't ventured beyond the solar system. We're heading towards Mars, the red planet. Attempts to find even traces of living organisms there started a long time ago. Mars has always captivated people's imagination. Just think of the countless works of science fiction dedicated to Martians and the possibility of life on Mars. This theme has intrigued visionaries like H.G. Wells long before the first satellite was launched into Earth's orbit. But what if all these stories carry at least a fraction of truth? Would we be able to accept such information? This question, for now, remains unanswered. Mars holds a vast amount of fossils, and there are powerful sandstorms occurring there. Mars has an atmosphere, although it is too thin. Carbon dioxide dominates its composition. It wouldn't be easy for a living organism to survive there, to say the least. Additionally, the surface temperature drops to 60 degrees Celsius. However, of course, there are creatures that can survive in very harsh conditions, in theory. They could potentially live on Mars, but there are some nuances. There needs to be geological activity to produce various essential substances. We should continue exploring Mars more and more actively. Then we will know more about its past, present, and future. The Opportunity rover, one of the two rovers, took on the task of studying the planet's surface. As part of the Mars Exploration Rover project, NASA has embarked on surface exploration. Many of the plains we see on the surface could have been Martian lakes. Furthermore, there's a hypothesis that water flows in the planet's subsurface layers, Perhaps there was life on Mars in the past. Can you imagine? You'll be even more surprised. After all, there is a theory that Mars gave life to Earth. It is suggested that at some point there was a collision between Mars and some object, possibly an asteroid, which resulted in a piece separating from Mars. Martian microorganisms remained on that fragment. Later, this part fell to Earth along with everything else, which gave rise to the emergence of life on our planet. Oh, there is still so much we don't know about Mars. During our journey to the next planet, we encounter difficulties, namely with asteroids. Their speed usually reaches 80,000 kilometers per hour, and their width can reach hundreds of kilometers in earlier periods. As a result of collisions, fragments of asteroids would break off, and some of them would later become planets, which laid the foundation for our planetary system. For example, we have learned that the age of Earth is approximately 4.5 billion years by studying the remnants of meteorites on the surface of our planet. However, some fragments of asteroids did not become planets. They encountered insurmountable barriers along their way. Jupiter, a giant planet. Compared to it, Earth appears to be just a small sphere. Multiple Earths could fit inside Jupiter. Due to its size, the gravitational force of the giant planet is very powerful. Under the gravity of Jupiter, asteroids that enter its zone of influence cannot transform into planets. It is also called a gas giant, and it's not without reason, as gas predominantly makes up its composition. So, if we were to land on the planet's surface, we would see firsthand that its upper layers are quite soft and we could easily sink into them. Furthermore, Jupiter, like its counterparts in the planetary system, is mesmerizingly beautiful. And this beauty is also deadly to all living things on the gas giant. There are very strong winds that race across its surface at tremendous speeds, resulting in the formation of various whirls and vortices which can be observed in Jupiter's imaging. The most notable of them is the Great Red Spot, which is approximately 300 years old and is 3 times larger than Earth in size. Can you imagine that? Jupiter is a deadly planet where, in addition to everything else, there are incredibly high levels of radiation. The amount of radiation it possesses attracts the strongest magnetic field to the planet. Indeed, it is better to admire such beauty from a distance, as it is unlikely that any force could calm down this majestic planet. As you can see, we have ventured not far from Earth, and how breathtaking discoveries we have made. We certainly know that this is far from everything the solar system has to tell us. And what do you think it will reveal to us someday about the history of the universe? Will it share the secrets of extraterrestrial life? Which fact has been the most interesting to you? And what did you already know about the history of our solar system? Jupiter is enormous. It could fit 1,300 Earths inside it. It's extremely hot here, with the planet's core temperature reaching almost 24,000 degrees. Unfortunately, we can't land on Jupiter. It's a gas giant with no solid surface, but it is possible to descend deeper into Jupiter's atmosphere. Look at those dense brown, yellow, red, and white clouds. It's because of them that the planet appears so colorful and striped. If we descend to the planet's center, we can see how its atmosphere, composed of hydrogen and helium gas, turns into a liquid. All thanks to the immense atmospheric pressure around Jupiter's core. There are many mysteries swirling around. Scientists have not yet determined whether it is a molten sphere, a dense liquid, or a solid rock. It is 14 to 18 times larger than Earth, regardless. We came here to see the Great Red Spot, a massive atmospheric vortex raging in the planet's southern hemisphere. It is nearly 8 kilometers taller than the surrounding clouds and almost 1.5 times wider than our planet. In 2017, space probes such as Voyager and Juno gathered a lot of information about the Great Red Spot. It turns out to be a monstrous storm that extends 322 kilometers deep into the planet's atmosphere, which is 30 to 100 times deeper than any ocean on Earth. However, these data might be imprecise, and the origins of the vortex could be even deeper. The Great Red Spot is colder than the rest of the atmosphere. The temperature on Jupiter's upper cloud layers is minus 148 degrees Celsius. On the other hand, the closer to the core, the hotter it gets. It is strange that the high temperatures observed on Jupiter were registered in the atmosphere directly above the Great Red Spot. There, the temperature reached 1300 degrees Celsius higher than the temperature of lava on our planet. Astronomers believe that turbulence caused by the vortex can lead to gravitational and sound waves, which may be the cause of overheating. However, at the bottom of the vortex is warmer than at the top. People have been observing the vortex on Jupiter for over 150 years. Astronomers once predicted that it would gradually slow down, shrink, or disappear completely, but that turned out not to be the case. After analyzing all the data obtained with the help of the Hubble Space Telescope, scientists were perplexed when they discovered that the winds at the outer boundaries of the vortex gained speed. The changes amounted to no more than 2.5 kilometers per hour over the course of one Earth year, which is very small. However, despite this, it still holds great significance. The wind speed at the edges of the vortex can reach an incredible 645 km/h, faster than a tornado on Earth. But it turns out that if you were in the center of the Great Red Spot, the spectacle would not impress you because the wind speed there is much lower. Scientists faced numerous challenges when trying to unravel the mystery of the Great Red Spot. It is unknown what fuels this vortex. It may be something within the planet itself. Being a gas giant, Jupiter lacks a solid surface, so there's no friction, the only phenomenon capable of weakening the vortex. The hot gases in the planet's atmosphere are constantly in motion, rising, descending, and swirling, similar to Earth, where colder and warmer air masses mix and merge, forming giant storms. Astronomers believe that at some point, several massive storms could have merged to create the Great Red Spot, and now it constantly absorbs cold gases from below and hot gases from above. Furthermore, the vortex can absorb smaller vortices, making the Great Red Spot even stronger. Unfortunately, due to the dense clouds on Jupiter, astronomers cannot see what is happening in the lower layers of the planet's atmosphere. Scientists have long pondered what might be hiding beneath the Great Red Spot. A massive volcano is unlikely, as Jupiter is primarily composed of gases and lacks a crust that could crack, allowing lava to erupt. There are several theories about why the vortex has such a color range. It varies from whitish and pale pink to bright orange and brick red. Scientists believe that the answer lies deep beneath the Great Red Spot, closer to the planet's surface. A colorless layer of gas can likely react to ultraviolet radiation from the sun, resulting in a red color. However, this is currently just a theory. Hey, you've also thought about it, right? Jupiter isn't the only star with a giant vortex. Another one, the size of our Earth, is raging on Saturn, and it's called the Great White Spot. How original! Vortices have a tail of white clouds surrounding the entire planet. This phenomenon occurs approximately every 30 years. This vortex actually starts as a spot, but then it expands more and more. Astronomers have discovered that the Great White Spot is a massive thunderstorm system. The size of the storm can produce lightning flashes more than 10 times per second. But the main mystery of the Great White Spot lies in its energy source. Some scientists believe it can draw energy from the sun, while others claim that the structure of the thunderclouds only makes sense if there is an internal heat source powering the wind. Nevertheless, powerful vortices exist on different planets in the solar system, and ours is not the only one. Let's move to Pluto, the largest of the known dwarf planets in the solar system, and explore its atmosphere. It extends high above the planet's surface and contains more than 20 layers of icy formations. By the way, the Moon also has an atmosphere called the exosphere, composed of helium, neon, and argon. It is about 10 trillion times thinner than Earth's atmosphere. A black hole is a place where gravity is so strong that even light cannot escape. However, sometimes they can behave like enormous galactic volcanoes. Black holes can ignite like volcanoes, but instead of spewing lava, they generate an enormous amount of energy. As a result, they leave behind huge voids in the surrounding gas and material. Recently, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that ignited many years ago. This event occurred in a galaxy cluster located approximately 390 million light-years away from Earth. The remaining crater can accommodate 15 Milky Way galaxies. During space travel, think twice before landing on unknown planets, or else you might find yourself in a place like Kepler. This planet is outside our solar system, and at first glance, it doesn't differ much from Earth. There are liquid oceans that evaporate, forming clouds instead of condensing. On this planet, rain falls not from water, but from stones. The surface of this exoplanet is covered with lava seas that reach depths of tens of kilometers. During the day, the temperature on 141 reaches nearly 28 degrees Celsius, which is enough for the magma in the oceans to evaporate into the atmosphere. Then, supersonic winds with speeds of up to 1.5 kilometers per second transport the vaporized rock to the planet's night side. The evaporated magma cools down, turns liquid again, and falls as a stone rain.
Scientists studying space believe that there must be life forms somewhere other than Earth. With the era of space exploration in full swing, humanity is searching for traces of life within our solar system. Among the many planets, the most likely place to find life is Mars. So why do scientists believe that there is a high possibility of life on Mars? In the late 19th century, astronomers observed Mars through telescopes and discovered that it rotates on its axis and its tilt is similar to Earth's. They also observed that Mars had seasons, which indicated that Mars has an atmosphere similar to Earth. These observations suggested that Mars is like a second Earth with its own unique features. In addition, in 1877, Mars moons Phobos and Deimos were discovered, further increasing interest in Mars. Since then, scientists have continued to observe Mars and have found evidence of water on its surface, leading to the possibility of the existence of life on the planet. I discovered that some areas of the surface were bright, while others were dark, and at the time, scholars believed these to be continents. They also thought that Mars had a dense atmosphere, and when they continued to observe Mars, they believed that the changing colors on the surface were due to the seasonal changes of plants on Mars. In October 1895, the American astronomer Percival Lowell made the following claim: "Through my telescope, I have watched Mars for a long time, and I am sure that there are canals made by Martians. And on the planet, there is a civilization and Martians live in society." In the 18th century and early 19th century, scientists had debated whether or not there was evidence of life on Mars. However, as humanity's space technology rapidly advanced, some scientists began to argue that we should go to Mars to find out firsthand. The first country to attempt to explore Mars was the Soviet Union in the 1960s, but they experienced many failures. In 1965, the US's Mariner 4 became the first spacecraft to approach Mars closely and send back images to Earth. The photos taken at that time totaled 22, but since it was an era of black and white photography, the image quality was not very good. Then, in November 1971, the US's Mariner 9 became the first spacecraft to successfully enter Mars orbit and sent back an enormous amount of data to Earth, including only 9 photos out of 7,300 taken, capturing about 80% of the Martian surface. The photos taken are diverse, including impact craters, the largest volcano in the solar system, Olympus Mons, and the erosion and deposition that occurred, almost showing the entire Martian surface. During this time, the Soviet Union was also tirelessly pursuing Mars exploration, but they didn't achieve significant results. Now, the United States, with billions of dollars, is embarking on the ambitious Viking project, focused on searching for extraterrestrial life. After the successful landing in 1980, Mars became a utopia. They successfully landed on the plains and immediately transmitted nearly 16,000 images back to Earth. In 1976, Viking 1 and Viking 2 successfully landed on Mars. After landing, they began searching for signs of life on Mars. They collected samples from the Martian surface and analyzed the atmosphere, but they couldn't find any trace of organic matter. However, the Viking lander had a fatal problem of being unable to move after landing. With all the exploration they're doing on Mars, it seems like they won't be satisfied with just one purpose. For the Mars exploration, NASA sent a rover with 6 wheels to actively explore various places. That's how the Mars Pathfinder was launched, with the intention of exploring multiple locations. The Pathfinder landed on Mars in July 1997. The Sojourner rover traveled around various locations on Mars for about 3 months, researching the atmosphere, soil, and rocks in search of life forms. However, once again, they did not find any friends of any life forms. Nevertheless, there were still significant achievements. It was revealed that the homestake event occurred about 3 million years ago, causing erosion that created the Ares Vallis. This means that our existence on Mars had an impact. After the success of the Mars Pathfinder, humanity continued to send exploration missions to Mars. The goal is to explore Mars itself or find evidence of water or life on Mars. First, Mars Odyssey found evidence of water and ice on the surface of Mars from orbit. In 2003, the European Space Agency's Mars Express mission discovered water molecules at the South Pole of Mars and succeeded in capturing images of ice. In 2008, NASA's Phoenix mission landed at the Martian North Pole, where it found water and ice and collected samples from the surface. The purpose of studying these Martian samples is to determine whether there is life on Mars or whether it could support life. Next, the Q-City mission discovered that methane levels on Mars vary significantly with the seasons. On Earth, methane is mostly produced by animal waste or the decay of organic matter. Therefore, methane is a powerful indicator of life. Of course, methane could also be produced geologically. Currently, researchers are actively studying where this methane comes from and whether it is produced geologically or by living organisms. Humans have sent dozens of Mars probes so far, but we have never found any signs of life or even traces of it. Why is there no life on Mars? First of all, it is very unlikely for Mars to be habitable. Its mass is only 1/10 that of Earth and its gravity is only 1/3 that of Earth's. If a 70 kilograms person goes to Mars, their weight would become only 26 kilograms. Because of the weak gravity, Mars cannot hold on to its atmosphere, which gradually escapes into space. Second, Mars is much colder than Earth and its magnetic field is very weak, only 1/8100 of Earth's. With such a weak magnetic field, Mars cannot block the solar wind, which causes the atmosphere to disappear. As a result, there is hardly any air on Mars. Of course, Mars has some potential for becoming habitable, and we are actively researching whether there is any microbial life on the planet, or whether it could support life in the future. Earth-like, Mars has carbon dioxide and water vapor in its atmosphere and even oxygen. However, the atmospheric pressure on the Martian surface is only about 0.006 times that of Earth's surface pressure, which is only 0.75%. With such thin air, it would be impossible for any living organism to survive. Compared to the Earth's environment, the Martian atmosphere is almost like a vacuum. This thin atmosphere also lowers the boiling point of water on Mars. The boiling point of water on Mars is only 27 degrees Celsius, so if humans were to be exposed to Mars' atmosphere, the water inside their bodies could be sucked out. Another interesting fact is that the boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure. If the external pressure decreases, the vapor pressure also decreases, so the boiling point decreases as well. In such an environment, even the most resilient organisms that are said to have high human survivability would find it very difficult to survive for an extended period of time. Mars also has extremely harsh temperatures. The average temperature on Mars is -80 degrees Celsius, and the surface temperature can drop as low as -140 degrees Celsius and rise up to 20 degrees Celsius. This temperature fluctuation is due to the thinness of the Martian atmosphere, which means that the molecules that make up the atmosphere are narrow and have less kinetic energy to maintain temperature and heat. This is why scientists have come to the conclusion that there is a very high likelihood that there is no life on Mars, as they have been studying the planet's physical characteristics since the 1960s when they began sending Mars exploration probes. Today's video discusses the process of exploring life on Mars by our Parliament and why scientists have determined that the possibility of life on Mars is very low. However, there are some who still insist that humans must colonize Mars, despite its harsh environment, and one such person is Elon Musk of SpaceX. As I mentioned earlier, today's video was a review of the movie The Martian, and I will return with the next installment in the series on extraterrestrial life.